Hello, everyone. You are welcome once again to today's lesson. And in today's lesson, we are going to bring the curtains down on sequences and series, okay, for core maths. All right, so this is going to be lesson 5 of sequences and series. Okay, so please take note. We are going to concentrate. We will be looking at, okay, solution to past questions or likely exams questions, but we'll concentrate, okay, on geometric progression questions. Geometric progression questions. Okay, so quickly, let's look at the first question that we have before us, okay, and see how best we are supposed to deal with it. Okay, I want the class to be interactive as always. So at a point, I will be calling you, or I will pause, then ask you to think through the question, then call you to tell me what your approach will be before we all come and solve it together. Okay, so you all talk. Everyone will talk today. All right. Okay, so now the first one, I'm going to do the first one. Then subsequently, okay, you be called to deal with it. So this is the question. If 3 minus x, okay, 6, 7 minus 5x are consecutive terms of a geometric progression, okay, with a common ratio r greater than 0, so your common ratio is positive, find the values of x, then b, the common ratio. Okay, so now let's look at the solution. So you've read the question, we are going to present the solution. My professors, are you there? Are you with me?
Yes, please.
Yes,
Okay,
please.
good. All right, now if these three are consecutive terms and we are saying that they form a GP, okay, what exactly is this information trying to tell us? If this sequence that you have here, and it's a finite sequence, if it's a GP, how do we determine that it's a GP? Any ideas? How do you identify a sequence or a progression as a GP? What do you use? Okay, Prof. Ama.
That if the terms have a common ratio.
Yes, consecutive terms, so common ratio. So this is it, because this is a GP and you are told that they are consecutive terms. Okay, they form a consecutive term, then this is what we are going to do. Okay, so solution to question 1. Okay, because this is a GP, so I can say that for a GP, I should have a common ratio. So it means my 6 over 3 minus x should be equal to 7 minus 5x over 6. Do you agree?
Yes, please.
Yes, please.
You agree? So now you can see that with this, we are more than good to go. So you form your equation in x, and you should be able to find your x. Is my point well made?
Yes, please.
So now what do? We are going to cross multiply. Is that not it?
Yes.
So this is now an equation. So we start with implication, or we can ignore. We will cross multiply. This will be 6 times 6, which will give us 36. Okay, and that will be equal to 3 minus x. Okay, then times what? 7 minus 5x. All correct. Okay, so you know we need to remove this bracket, combine like terms, if any. So if you remove 3 times 7, okay, so 21. This time this will give you minus 15x. Okay, minus, I hope you are following, minus 7x. Then this time this will give us plus 5x squared. Okay, obviously you can see a square term, a square term. So it means we are no longer dealing with what? A linear equation. We are dealing with a quadratic equation. So if you don't know how to solve quadratic equation, you will get stuck here. So again, that's why I tell you in math, you don't choose and pick the topics that you like. Okay, because you don't know where you will meet. Okay, it. So obviously I'm going to work on this. Okay, I would have moved everything, okay, everything here and combined everything, okay, directly. Someone will simplify this side before moving this one, but I'm going to combine everything. If you are not this matured, please do it systematically. Though whatever you write, if you were supposed to skip, okay, I mean, if you were supposed to simplify this side before writing what I'm going to write, it won't attract any marks. But it's better to play it safe. Okay, so at this point, I know I'm going to get a quadratic. My first, okay, term, which is supposed to be the x squared term, is positive. So I'll write that one first. So 5x squared. Then it's this one that I will move here. So I'll combine followed by my x term, but this and this will give me minus what? Is it 22?
22.
Okay, x. And if you bring this one here, it will be 21 minus 36. And that will give us minus, I'm waiting, 15.
15.
Okay, so 15 and it's equal to 0. So we are, okay, dealing with this quadratic equation. So you are supposed to solve this quadratic equation. However, okay, before you solve your equation, check whether you can reduce. That's the first point of call. Reduction means you can divide by a common numerical factor. And here you don't have a common numerical factor apart from 1. Okay, take note. Then after that, you check if you can solve by factorization. So if your quadratic expression here is factorable, then it means you can solve by factorization. If it is not, then you cannot. You have to resort to either the completing of squares or the almighty formula, the quadratic formula. Okay, but between the two, always go for the formula. If it's when you are restricted that you use completing of squares. But can we get factors of, you multiply 5 and minus 15, and what would that give us?
Minus 75.
Okay, so minus 75. Can we get factors of minus 75, which when we add, factor pair, which when we add, we'll get minus 22. And when you multiply, we'll get minus 75. Any factor pair?
Please.
Did you say no or yes?
Yes.
Okay, so give me the factors.
3 and negative 25.
3 and negative 25. Please, do you all agree?
Yes, please.
Okay,
Yes,
iPhone, unfortunately, I can't call you that. Please change it to reflect your name. Okay, your hand is up. Okay, so let's continue. Okay, so when you are ready, then you can talk. All right, so you will get 5x squared, then minus what? Is it plus or minus? The values, all of them, one of them must be negative. So it's the bigger one that must be, the bigger one that must be negative. So minus 25x, okay, then plus what? 3x, then minus 15. So you use your two-factor pair to split this. Okay, and that will give us what? Is equal to 0. Okay, so at this point, we are in a comfortable lead. So we factorize by grouping. I've told you. Okay, and I'm saying it again because I have new professors on board. Please, when you are grouping, don't use your bracket to group. It can put you in trouble. So always group the first two and the last two mentally and factorize. So first two grouped mentally and factorize, I will get 5. X will also come out. So I will get X, yeah, then minus 5. Okay, last two grouped and factorize. Okay, if you don't change it to reflect your name, I won't call you iPhone. Change it to reflect your name unless you don't know. Okay, because as one of the rules, we know that we are not supposed to enter class with such a name. Okay, so plus, then I take this one to 3 out. Okay, then I'll get x minus what? Minus 5. And that's equal to 0. So on that note, what am I going to get? I'm going to get 5x plus what? 3. Then my other factor will give me x minus 5. It should be equal to 0. So this particular step that I'm going to write is very critical, where you equate each of the factors to 0. So 5x plus 3 should be equal to 0, or x minus 5 should be equal to 0. So now you come and solve this linear equation, And please take note, and I'm repeating again because we have new professors on board. The connector here is strictly or. you cannot ignore this connector, or you cannot use a comma or end to connect these two, okay, equations. Take note, the connector is completely, okay, or. iPhone, I've told you, change it to reflect your name. I called you initially, you didn't respond. All right, so now what do we have? We are going to solve this, and that will give us what? We write 5x will be equal to what? Minus 3. Then you write it again before you divide. Okay, remember the or, okay, which is supposed to be here. You moved on to the next page. So write the or again. Then you come and write x is equal to what? 5. With this one, x is solved for. Now we are going to complete solving for x here. And that will give us minus 3 on what? On 5. So you were asked to find, okay, so I'll write, therefore, okay, my x is equal to minus 3 on 5. Or I should say 5. Okay, any issue with my presentation? Is there anything that you think is vital that I have not written? Can you see anything? Okay, Prof. Snyder.
Sir, please, I don't think there's anything wrong with the but I don't get the last part where the 5x is to.
Where the 5x is what?
The 5 divides 3.
The 5 divides the 3 here. Is it here?
Yes, please.
Oh, so you if I give you this equation and you are solving, you understand this step. You move this one to this side. You are solving a linear equation. So if I give you this equation to solve, how will you solve it?
It's okay.
Your hair like mine. All right. Okay. Or I should give you permission to go and eat.
No, please.
Oh no, in fact, it was a rhetorical question. I wasn't expecting an answer. I was just pulling your legs. All right, okay. So now, okay, Amma, do you see? So you don't see anything wrong with my presentation?
Mr. Ackman,
Mm-hmm.
please, we are solving A's question, but you've used 1 to represent it.
I'm solving what?
A.
Question A. But I've used
No,
1 to.
question 1A.
Question 1A. Okay, this general information, very good. Okay, so please take notes. First of all, we should have extracted this. We didn't extract. You get it? Our
Yes.
presentation doesn't start with giving. That is 1. Are you with me? Okay, so the one that we have there, this one, the information that we were supposed to attach to the one that we have here is the consecutive terms of the sequence. So we should have written giving whatever that we have there before we come to A. So A is supposed to be here. So what we are doing here is geared towards solving A, but it should have been 1. Okay, then you write giving, then you extract your sequence 3 minus x, okay, 6, okay, then what 7 minus what 5x. Is that okay?
Yes.
Okay, so take notes. Giving, then therefore. Okay, Prof. Kimberlin. I guess you were iPhone.
No, please.
Okay.
Please, I wanted to ask that if you're using the calculator, how would you be able to get the values, the negative 25x plus 3x?
How will you be able to get this? You want to use your calculators to get the factors?
Yes.
Hey, soft life. Hey, Kimberly. Madam Soft Life. Okay. All right. Please, you can use your calculator to solve. And maybe that will guide you to get the factors. But take note, as for the factors, okay, you should be able to get it. You know, we solve quadratic equation in JHS. In JHS, one of the equation that we used to, like, I believe was quadratic equations, especially if you can factorize. And in JHS, usually we use the factorization. We'll give you a situation where you can factorize anyway. Okay, so please, okay, at this point, I'm not going to encourage you to use your calculators to get the factors. Okay, look for factor pair. You know, if I'm looking for 75, okay, I know, let me show the, hide the negative. If I'm looking for the factors, I know one will go with 75. I hope you are with me. We are looking for the factor pair. So you go and look for the other one. 3 will go with, because 2 obviously cannot be a factor of this. 3 will be a factor. And 3 will go with what? With 25. Is that clear? So I'm
Yes,
guiding you
sir.
as to how to get your factors. Okay, then if you are close by, what do you call your JHS, please go for part of your fees. I will take it later. All right. Okay, so this is what we have. But you know, this one and this one, okay, if I combine, usually you test. If I add, because one of them should be negative. If I have products of 2 numbers giving me negative, then it means one of them should be negative. But the result that I'm looking for here, okay, please take note. Please, those of you who understand, move on to B whilst I'm explaining so that later you can cross-check. Is that okay? So that it will not be boring to you. All right. Okay, then, okay, with this one, I know the product should give me minus 75. So one of them should be negative. Both cannot be negative, both cannot be positive, because 2 negative, if I multiply, I get a positive result. Okay, 2 positive, if I multiply, I also get a positive result. However, because my coefficient here is negative, it means always the bigger one should be negative. So the bigger one here should be negative. Okay, the bigger one here also should be negative. Okay, but this one, if I add, obviously I won't get negative 22. This one, if I add, you see that I'll get negative 20. So it means this will be the factor pair. Otherwise, you go and look for the other factors. Factor pair, and you test as well. Prof. Kimberly, are you fine?
Yes, sir.
Okay, very good. All right, so now we move on to B. You leave, please, all that I've done here, no spaces left, no line, okay, left on that. Though you see a space here, there is no space, please. I don't have lines, so obviously, but now you leave a line before you move to B. Remember, you only leave lines when you are moving from a sub-question number to another sub-question number. So B, we need to look at what's the common ratio. Okay, and you should know that the common ratio R. So here you are told that the common ratio is R. Okay, so I can write, but I can use R because R has been defined, and I can conclude with it because it has been defined already. So R, we know, is equal to 6 over 3 minus X. Is that clear? Because any of this ratio here will give you your R. So you use one of them. But you know that if I use this involves bigger values. So it's better you go for this. However, if you use this one, you get the same result. Is my point well made?
Yes, please.
Okay, but here is the case you have 2 values for X. Please take notes. Here is the case you have 2 values for X. Okay, very soon I'll tell you that there was something important in the question that we should have underlined, but we didn't. Okay, very soon. So here I'm going to write if, okay, X is equal to the first value. Let me start with the pretty value. I always want, okay, easy one first. So if X is equal to 5, the order in which you move doesn't really matter. So let me see, someone has a message for me. Okay, Bella. Okay, so this will be equal to, so if X is equal to 5, our R will be equal to 3 over what? Sorry, did I say 3? 6 over what? 3 minus what? 5. Okay, which will give us R to be equal to, a hand is up, Bliss.
Mr. Hartman,
Mm-hmm.
are you trying to say that because they are saying the R is greater than 0, we can't use the negative
No,
fraction?
I haven't said that. I said, okay, you are supposed to test for the R for each of these values. Only that I didn't want to move in this direction. I want to do the easy one first. I'm working with the PT value first. Then after that, I come to this. The order doesn't really matter. Okay, you should always have a plan. Okay, so I want to do the easy one first before this will stress me. Then I'll have energy for this. You get it? Okay, so not that I've discarded the first S value. No, I have not. So this means that this implies that your R, let me finish. I'll give you time to ask questions. So, okay, Prof. Ella, please hold on, okay? All right, so you get 6 over what? 3 minus 5, and that will give you minus what? Okay, 2. So it means your R will be equal to what here? Minus 3. Am I right?
Yes.
Okay, so we are not done. Let me see whether I have an S. Okay, no, the next one is an S, so I will continue here. So I'm assuming this is my next page. It didn't go there. My space was not enough. So I rule a line. If you don't rule a line and you come and write, whatever that you have here will be regarded as a rough work. So if you are assuming this is your next page, rule a line. So if R is equal to the second value is what? Minus 3 on 5. Okay. Did I say R? X, forgive me. Comma, your R will be equal to, so let me write it well. Okay, it is X. My professors, I hope you are following. Okay,
Yes,
so
sir.
R will be equal to, let's go and substitute. So 6 over, here we are going to get what? 3 minus 3 on 5. So to give us plus 3 on 5. Is that clear?
Yes,
Okay,
sir.
which will give us, this is equal to 6 over, okay, give me the single fraction form of what you have there. You can use your calculator, I'm waiting.
18 on 5.
Okay, let me bring this one down a little. Okay, it's like going to interfere with what I have there. You will not encounter this problem because you write in lines. So it will give you 6 over 18 on 5. Okay, which in effect will give us, use your calculator, give me the value.
5 on 3.
Okay, 5 on 3. Okay, but you know, okay, we are going to draw our conclusion. Remember, can we say that therefore R is equal to minus 3 or the mixed numbers version of this?
The mixed numbered version.
Okay, so you can see that this must be discarded because we are told that R must be greater than 0. This is very critical. So in this case, you draw your conclusion. Therefore, R is equal to the mixed, okay, number version of this, which will give you one whole number 2 on 3. Is my point well made? So if you don't pay particular attention to this, you know this one, you know that you would have concluded with this one as well. You know. Okay, so just be honest. So anytime, that's what I've told you, anytime you read question and you see salient parts underlined. So this is very critical. You see that usually we just say with a common ratio, I won't give the condition. So immediately the condition is given, underline the condition because we want you to make use of that condition, okay, going forward. All correct?
Yes, sir.
Okay, and with this one, there is only one variable. When what you have there contains only one variable, you need to generate only one equation, okay, to solve for that variable, which is exactly what happened here. We generated this equation and that helped us to find the variable x. Now let's move on to the next one. Okay, so with the next one, you are given a sequence. So this time around, I believe, okay, you should know how we are going to proceed. So solution. Okay, because of time, I said I think I have to change plans. Wow, let's do this one, then I'll give you water break. Okay, so now what do we have? Okay, we've been given, you can choose, so question 2. You can choose not to write the given and write maybe 1 over 32, okay, m, okay, 1 over 8, comma, then n, comma, then your ellipsis. So this is the sequence that you are dealing with. And you know that this is a GP. So don't go and check whether, okay. So we need to find the values of m and n. Okay, we are finding the values of m and n. And please, if you're asked to find the value of anything, don't conclude by saying therefore the value of no. Just write, if you find it, if it's m, just write equal to and state its value and write your therefore there. Okay, save that English for your English teacher and give us the math. We need the math. Okay, all right. So now that was just by the by. Okay, so this is what we are going to do. This is a GP. However, unlike the first one that I said, we had only one unknown. Here, how many unknowns do you have in your sequence?
2.
2. So it is telling you that you cannot use one equation to solve for 2 unknowns. So you have to generate at least 2 equations. And anytime you have 2 unknowns, there is no way we'll give you, okay, 3 terms. We'll give you more than 3 terms so that you can generate, okay, your equations easily. So now this is what we are all going to do. This will be our approach. So like the other one, so with this one, for an it's a GP. So for a GP, okay, now you know that m divided by this. So I'm going to form my first equation. M over 1 over 32 should be equal to 1 over 8 divided by m. Do you agree? Hello, do you agree?
Yes.
Yes, please.
Okay, so I am going to simplify this side, okay, before I label that equation. That's my first equation that I'm generating, or our first equation that we are generating. So this implies that this will give us m times what? Okay, 32. Is that not it? Over 1. As you match, I will know that this will give me, okay, 32m. Okay, so but I'll write it just to explain. So it will be m divided by this, which will be m times the reciprocal of this. So that will give you 32 over 1. Is that clear? And that should be equal to 1 over 8 divided by what? M. So it will be 1 over 8 divided by m, which will be times 1 over m. Is that clear?
Yes, please.
Sure.
Yes, please.
Okay, very good. So we are still not done. So this gives us 32m. Okay, it's equal to 1 over 8m. Are we in agreement?
Yes, please.
Okay, so what again do we do here? We cross multiply. So let's see what we are going to get. You cross multiply because I've told you your equation before you label, it shouldn't involve a fraction. It shouldn't involve brackets. Okay, so here it involves, okay, a fraction. So we won't label it at that point. So when we cross multiply, we are going to get 32 times 8, and that will give us
256.
okay, so 256 m squared is equal to 1. All correct. Hello,
Yes.
all correct. Okay, very good. Now let's go and form generate. So I'll call this equation 1. I could have asked you, mature. I know this is an equation of a particular form that I could have taken it to another form, but don't worry. For now, to keep it like this. Okay, so what do we have? Okay, the next one, I can say that my 1 over 8 over m should also be equal to what? N, okay, over 1 over 8. You get it? So, and I'm going to generate my second one. 1 over 8 over m should be equal to n over 1 over 8. All correct? Okay,
Yes.
so
Yes.
which also implies that I'm going to get 1 over 8 over m. So 1 over 8, okay, divided by m. So it will be times 1 over m. Okay, which will be equal to n, okay, divided by 1 over 8. So it will be times 8 over 1. Is that clear? Okay, so which in effect here we are going to get 1 times 1, which is 1, over 8 times m, which is 8m. And that will be equal to, okay, n times 8 over 1. So it will give us what? 8n. All correct.
Yes, please.
Yes.
Okay, all right. So now let's see what is going to happen, okay, in this one. So again, let's cross multiply before we label this equation. So if you cross multiply, you are going to get 1 to be equal to 64 mn. Am I right?
Yes.
Prof. Kimberlin.
Hello, sir.
Prof. Kimberlin, I'm here.
I wanted to ask, why is it that in the first part we use M twice, but in the second part we only use like N once?
Okay, it's the nature of our movement. We are looking at consecutive term, okay, ratio. So we did this consecutive term, which gave us M over this. Then we moved to this consecutive term, which gave us M over that. So we've used two consecutive term ratio to form a proportion, which gave us this equation. Is that okay?
Yes, sir.
Okay, then you also go and you can use this. You can see that you were left with only this and this. Is that not it?
Yes.
But if you do that, that will not, if you do only this, that will not give you, okay, what do you call it? That will not give you a proportion, to give you a ratio. But you need to form a proportion before you can get your equation or your relation. Is that clear? So you will need another one. So you go to the one that is close.
Okay. Thank you.
You are welcome. Prof. Ella.
Please, I was asking and wondering, in equation 1, like instead of going for another equation, can't you just, divide both sides by the coefficient of M squared, then square root it?
Okay. You remember I said before I wrote this, I said I know this is of a particular form that, okay, I could have done something before labeling, but let's keep it for now. Remember I said that?
You did.
Yes. So you keep it here for now. Don't worry. We'll deal with it later,
Okay.
in the near future. So if you can see that, okay, and you go and solve for your M, that is fine. Now I will get the two equations, then I'll study the equation and see which one will be more useful. Then I start with that one. You get it? So this can be labeled.
Yes.
So we are going by the basics. So this will now be equation what? Equation 2. Now I need to work on equation 1 and 2. Okay, but if you look at equation 2, it contains two unknowns. However, equation 1 contains only one unknown. So I can take equation 1 and make M the subject. Okay, in that case, solve for M. Then when I know M, I can substitute that into equation 2. So this is where exactly what she said will come in. So I will come and write from 1. Okay, I'm going to work on equation 1. Okay, I am making M the subject, so I will get M squared. Okay, will be equal to 1 over, okay, 256. Is my point well made?
Yes, please.
Okay, I'll give you another way. We can play with it. Okay, how to. So I'm looking for M. So it will be root of M squared will be equal to root of, okay, 1 over 256. Do you agree?
Yes, please.
So that is what you write. That is what you all write. My professors, are you there? Is that what you all write?
Yes.
Yes, please.
No.
Okay, so what will you write?
Sir, please, you cancel the square with the square with the root sign.
Oh no, I'm
And
talking
leave
about
M.
here. That will be you are giving us the next step. Okay, I'm talking about here. Is that what you
Yeah.
write?
Sir, yes,
what
that's
you
okay.
write. Okay, all right.
No, please.
Okay, so who said no? It's Lynette. Okay, Lynette, what will you write?
That's on minus.
Very good. Clap for her. Please, I want to hear you clapping for her. Remember, I told you, anytime you are taking the positive square roots, okay, and it is what? Even square roots or even roots, square root, fourth root, what have you? Ask yourself that vital question. Have I said it or not?
You have.
Yeah. So these are the low-hanging marks that I've given you all the tools. Okay, and I'm so happy. In fact, initially I was getting worried. I was sad. Okay, until she came in. Okay, because it was being unanimous. Okay, anyway, so please, there should be plus or minus here. Very critical at this side. Because you don't know the M. The M here can be negative, it can be positive because it's just a term. Your N can be positive, it can be negative because it's just a term. Is my point well made?
Yes, please.
Okay, so this now will give us our M. Okay, to be equal to, so help me. This one is just calculator work. Plus or minus, use your calculator.
1/16.
1/16.
Yes, please.
Okay, so you know, okay, that we cannot conclude with, and we are not even concluding now. So you take, let me separate. So it means M will be equal to, okay, plus or minus. So I'll go for the plus first. 1/16 or minus 1/16. Do you agree?
Yes, please.
Okay, so you are going to, once you have two values for N, okay, it's likely you will get two values for, what do you call it, N. Okay, and the relative math students, okay, remember when we did the static equations, okay, this situation also came in. So you go and test if M is equal to the first value 1/16, okay, then we are going to get 1 will be equal to 64 into your M, which is 1/16, then times your N. All correct?
Yes, please.
Okay, so 1 will be equal to, any reduction here, give me the simplified version of this.
It's 1/6.
Oh, 1/16, forgive me. Okay, thanks for prompting me. Give me the simplified version of this. Just use your calculator to multiply these two. This is not a power. This it will give you.
4.
Okay, so 4n. Am I right?
Yes, please.
Okay, so I write it again before I divide over 4/4. Okay, so in this case, my n will be equal to 1/4. Am I right?
Yes, please.
I'm going to continue here, assuming this is my next page. Okay, so if m is equal to its second value, the negative, which is negative 1/16, okay, comma, it implies that we are going to get our 1 will be equal to, we said it will be 64 into minus 1/16. Okay, then n. Okay, so we are going to get 1 will be equal to what? Okay, minus 4n. Am I right?
Yes, please.
Write it again before you divide. So n will be equal to, again, 1/4. Am I, sorry, minus 1/4 here. Am I right?
Yes, please.
Okay, so we are going to draw our conclusion. And remember, this one is going to be therefore, okay, m is equal to, what is the first m value? 1/6. Okay. And, okay, or you can use comma. Yes, please. 1/16, forgive me. I guess that was what you were drawing my attention to. Okay, when m is equal to 1/16, what was n? N is equal to 1/4. Okay, or m is equal to its second value, minus 1/16. Okay, and
Answer.
yes, please.
So sir, please can you say that m is equal to plus or minus 1/16?
You don't conclude with plus or minus together. You have to split.
Okay.
And because here you have two values for m and two values for n, okay, it's better you indicate the m and its corresponding n. So that's why I am doing that. M is equal to this and n is equal to that, or m is equal to second value and the n, okay, will give me -1/4.
Okay, sir.
Okay, all right, Prof. Amma.
Sir, please. I remember that you said if the plus or minus beside the root sign is not really necessary, we shouldn't write it because we'll get a positive answer. So, sir, look at the geometric progression. The first number is positive, but the m is, we are getting a negative number to it. So are we supposed to also conclude with a negative one? Because I'm sure the m is supposed to be a positive number.
You are
Or a
sure?
positive value.
Okay, so we are going to form this sequence with the m and the corresponding n and see whether indeed it will be geometric. Okay, I won't answer your question. After that, then you take your own answer. Is that okay? So let's substitute and see whether, okay, so assuming, so 1/32, okay, that's what we have, comma. Our first m is what? 1/16, okay. Then comma, 1/8. The n, 1/16 gave us 1/4, am I right?
Yes, please.
Okay, check. Does it make sense? Will you get a common ratio?
Yes.
Okay, let's go for the other one too. So this is a possible sequence based on the information that you are giving. So let's check the other one too. So 32. Okay, 1/32, comma. So minus what? 1/16. Is that clear?
Yes, please.
Then comma, 1/8 is intact. If this is minus, this will give you -1/4. So check and see whether, okay, you still get a common ratio. Oops.
Okay. There, I've gotten a common ratio.
Okay, so you can see that here, okay, because you have two values, it means possibly you are going to have two sequences, possible sequences.
Okay.
All right. Okay, so is your question well answered?
Yes, please.
All right, so that's the more reason why you have to take notes, or you don't strictly take the positive, unless the question said m, okay, if I wanted you to conclude with the positive, I would have said m, okay, n greater than 0. So in that case, you conclude with only the positives. You get it?
Yes, please.
All right, so take notes, okay, of some of these, okay, tricks, okay, before you fall victims. Okay, so at this point, please, okay, I'm going to give you your water break. Okay, so 8:20, by 25, you should all be back. Okay, all right. You are welcome back from the water break. Okay, so quickly, let's move on to our next, okay, set of questions. Okay, so question 3. Sorry. Okay, so let's look at the solution to question 3 as well. Okay, and again, we will pause. All right, so Kimberly, I want to send the message to me on WhatsApp so that I can, okay, reply there too. Okay, thanks for prompting me here. Okay. All right, so solution, that's what we write next. Okay, Kimberly, I guess you are trying to follow. I know it will be difficult if you've not been taught. Okay, but try and follow. Later when you get the video, you'll be able to connect. Okay, dot the I's and cross your T's. All right, so here, the fourth and the eighth terms of a GP are, so this time around, what you have there are in statement from English. So we are moving to the word problem form. Okay, and those of you who don't like word problem, don't worry. Every word problem question, just break it down, okay, into simpler, okay, or simple units. Then later you put them together. So that's what I will also do to guide you. Okay, so find the possible values of A and R. So it means find the first term and your common ratio. sort of. All right. So a GP, I underline GP because I will know the sequence that I'm working with. I'm told the 4th term and the 8th term will be this and this respectively. Okay, so it means I've been given, so this is what I'm going to do. I'm going to extract as well, but I will extract whatever I have there in terms of the English, okay, in terms of maths. So I'll move from English to maths. 4th term, what is the notation for 4th term? So let me write a question number 3. Hello, what is the notation for 4th term? Under any sequence or series. Notation for 4th term. Hey, my professors, are you there? Prof. Blaze, I was expecting the whole class to respond.
U sub 4.
Okay, so giving U sub 4, okay, is equal to 24. Okay, and okay, the 8th term, we know is U sub 8, okay, likewise, and that will be 8 on 27. Amma, your hand is up.
Please, the second question is solved. You said you give an alternate solution.
Oh, okay, so let me go back. No problem, maybe I will say it. It's just about how to get your M. Oops, I've gone more than enough. Okay, so at this point, okay, someone, instead of making, remember I told you, you can also see this as a quadratic equation and you can solve by factorization. So you can write 2, 5, 6 M squared minus 1 is equal to 0. Okay, so that you see this to be difference of 2 squares. You know that is the same as 16, okay, M all squared. Okay, minus 1, okay, also squared is equal to 0. So you can use 16 M plus 1 into 16 M minus 1 is equal to 0. Then you end up getting the same result if you solve. That's what I wanted you to know. But remember, I told you, even in that one, I told you that I always want to, because it's a special quadratic equation where there is no linear term, I can always make M the subject. So I will make M the subject. But, okay, it's because of this. Okay, assuming if you went this route, okay, and you didn't take the square root, you see that one of them will be discarded. But those who will use the factorization, okay, automatically they will get the 2 values. So though this is simple, okay, it is a little risky, especially if you forget to introduce the plus or minus. Ask yourself that vital question for the introduction of the plus or minus. You get a point?
Yes, please.
Okay, all right. So I think now I can move on. Okay, so thanks for drawing my attention. Okay, pardon me, it was due to old age. All right. Okay, so this is what we have. Okay, so we've extracted the information, okay, mathematically. Okay, now let's see how we are going to deal with it. Once the information is about U subs, meaning, okay, particular terms, U sub 4, U sub 8, then it means the question wants you to use the formula for U sub n for this particular GP. So we need to go and generate that formula. Not that we are going to generate, we know the formula. Okay, and the formula will help us do something going forward. It is very easy, don't worry at all, you get it. So at this point, I'll write but. Okay, for an AP, I can even choose not to write a but. Let me straight away be consistent. Okay, for a GP, so for a GP, okay, my U sub n is given by which formula? A r to the power n minus 1, all correct?
Yes,
Yes.
please.
Okay, so can I say that this implies that this U sub 4, okay, will be the same as A r to the power 4 minus 1, which will give me A r cubed.
Yes, please.
Okay, and that is equal to 24. You agree?
Yes, please.
Should I come again? Who wants me to come again today? I've not asked this question.
Jeez, I.
Okay, so next time, okay, if you don't get it, just put up your hand and Zachman, ask your question. Okay, I'm waiting for your question. All right, okay, so this is it. Who was that? Was that Kimberly?
Christine.
Christine, okay. Christine, you know, we are just being smart anyway. Okay, so if I don't know A, I don't know R, but I know N. So I know so use up what 3, or let me use up 4 will be equal to A, R, then 4 minus 1. Do you agree?
Yes, please.
Okay, which will give you
AR cube.
AR cube, and that's exactly what we have here. So I've written this one in terms of AR. But that we are told is 24. Is that not it?
Yes.
So I'm going, once you are looking for 2 unknowns, like I said, you have to generate 2 equations. So this becomes equation 1. And, okay, use up 8. Let me see, Christine. Okay, let me see whether you've understood. Use up 8 in terms of AR will be, A and R will be.
AR 8 minus 1.
Okay, so you can do that mentally. 8 minus 1 will give you
7.
7. So straight away, instead of going to spread. So you can even do that as a rough work. It's not necessary. So that's why we give the marks. You get it? And that we
Yes.
know we are told is what? 8 on what? On 27. All correct.
Yes.
Okay, should we label the equation here?
Yes, please.
Okay, we can, but we shouldn't. Remember, I just said, okay, make sure your equation, okay, you do pedicure and manicure. Make it beautiful before you label it. So clear the fraction, remove brackets, if any. Okay, no brackets, but you have fractions, so you clear before, okay, labeling it. Is that okay with you? Hello,
Yes.
okay, so now, okay, the whole class. So this implies that I'm going to get 27 AR to the power 7 is equal to 8. Then I label this as equation 2. All correct.
Yes.
Okay, so at this point, okay, you have 2 equations, all of them in A and R. Okay, so let's see how you'll be able to solve for A and R. Okay, so any ideas at this point, at the normal circumstance, okay, you should be on your own. Okay, I've helped you more than enough. Okay, up to this point. So please tell me what you will do in this situation with these 2 equations. Okay, Prof. Herbert.
Okay, sir. For the first equation,
Mhm.
you make A the subject.
You make A the subject. Please, did you hear
Yes.
him? Okay, so we are going to do that. Okay, so let's see. Okay, so you just say what you do. Then I will write everything together. So you make A the
Okay,
subject, and after that, what do you do?
and for the second equation too, you make A the subject.
Mhm.
Then you substitute so like okay, when you make A the subject for the first equation,
Mhm.
you name that as your equation 3.
Mhm.
And when you make A the subject for the equation 2, you name that as equation 4.
Mhm.
So you substitute any of the equations into each other.
Okay. In actual fact, you just equate. You equate your
Yes,
2
sir.
resultant equation. That's what you mean. But please,
Yes, sir.
if you make one of the variable the subject in one of the equations, it's not necessary to come and make. Just come and substitute that one into this one. It's okay.
Okay, sir.
Okay, so don't go and make any before you equate. Just substitute. When you want to use substitution, just make one of them the subject and substitute into the other, period. Okay, so now, okay, very well done. Okay, very good. So let's look at Prof. Herbert. Let's look at what we have here, the whole class. Okay, so now this is your presentation. You have the concept. Your presentation is equally important. So from 1, someone could have made A the subject in 2. So you will go for the one that, but it is better you go for this, okay, particular one. However, though I said in a situation where you can avoid, okay, change your subject, that will not result in fraction. You avoid, but here you can't avoid. So hard way, the only way. So what do we go from 1, comma, that's what you write. Don't write equation. Equation either in full or in short. Then 1. This is red equation 1. Take note. So from equation 1, comma, you are making something the subject. So I'm going to have, you said we are making A the subject. So A will be equal to 24, okay, over what? R cubed. Am I right?
Yes, please.
Okay, and like I always do, you can label this one equation 3. Okay, but remember I said if I work on one equation, okay, I will just give my equation that I worked on its name and attach a letter to it, maybe A, for me to know that this is a baby of what? Equation 1. It was equation 1 that I manipulated to get this. I worked on only one equation. So at this point, I'll write equation 1A, okay, into, and I've told you don't write put, don't write substitute. If you want to write these two, you have to write putting, substituting, but I've told you it's not necessary. Just write equation 1A into, so we know that you are putting that one into. So that will give us into equation 2, okay, comma. So wherever you see A here, it is now this. So let's see what will happen. So we are going to get what? Okay, not that pretty. So we get 24, which is our A, over R cubed. Remember, we are substituting, so we'll put it in brackets for safety reasons. Then times what? R to the power 7. Okay, and that should be equal to, okay, oh, where did I? I should have used this one. So forgive me. Let me go and I used this one in the stead. All right, so forgive me. Let me do the right thing. Okay, so this can equally happen to you. So learn from my, okay, obvious mistakes. Okay, so now I will get 27, okay, into my 24 over R cubed. Okay, being equal to what? 8. Is that clear? Sorry, times, I forgot the R to the power 7. What is happening? Okay, do I need permission to go and eat? I've started exhibiting symptoms. All right.
No.
So you give me permission to go and eat. Is that how you are? All right,
Yes.
so R to the power 7. I guess it's Aduma. Aduma no better side Aduma. All right.
It's not me. Oh,
Hey, hey, Aduma, it's not you.
no.
Hey, then this one, the person is really wild. Oh. If it's not you and it's a different person, then the person is wilder than you.
Yes, why would I?
Okay, so this is what we have. So let's go. Let's simplify. Make the work easy. You know that these are indices. They have the same base. So now you multiply this and this, which you give us. Let's go. The rest is calculator work. Let's go. I'm waiting. Hello, we are almost done. So hurry up.
Mr. Ackman,
Yes, please.
please can the R cube cancel the R to the power 7?
It can't. You just. I asked you to multiply 27 and 24 for me. I'm waiting. Then we'll do. I told you. Okay, use indices. It will not cancel per se, but we'll subtract it from this. So it will give us R to the power 4.
648.
Okay, 648. Okay, so that would be times R to the power 4. Do you agree?
Yes, please.
Okay, it's equal to 8. Please, who wants me to come again? Wow. Okay, I barely get. Okay, no response for this question. Okay, so at this point, again, we are in a comfortable lead. You write it again, you are making other subjects, divide by the coefficients, then you know what to do next. So let's go. I'm going to write it again. So I will get 6, 4, 8 R to the power 4, okay, over 6, 4, 8 is equal to what? 8 over 6, 4, 8. Okay, so R to the power 4 will be equal to, let me clear this before somebody thinks it's part of the solution. I'm waiting. We are almost done.
1 over 81.
Okay, so this will give you 1 over 81. Okay, so now I'm going to take the fourth root. So fourth root of what? R to the power 4. Okay, will be equal to fourth root of 1/81. Do you agree?
Yes, please.
So is that
Yes,
what
please.
you all write?
No, sir.
Okay, so what will you write?
So I'm going to try.
Just try.
Sir, plus or minus the fourth root of 1/81.
Okay. Why plus or minus?
No, please.
Sir, because of the fourth root.
Very good. I just said anytime you take the even root, ask yourself what you are looking for. Okay, can it be positive? Can it be negative? Do you have enough information to say that it's really positive, it's really negative? If not, you introduce plus or minus. What is R? Is R not the
Plus or minus.
Yes, I think you said it 2 years ago. I have now heard it. Okay, your network is back. It's really bad. Okay, so now you can see that I'm looking for R here is the common ratio. And common ratio, we all know we can get a negative common ratio and a positive common ratio. And the question specifically didn't tell us that our R should be greater than 0 or it should be less than 0. So even whenever you take the even root, it means that question is satisfied. So I will introduce plus or minus. Without that, we are doomed. Safa.
Yes, please.
Okay, so that gives us what? Here will be R, and that will be equal to plus or minus 1 over.
So 1/3.
Okay, 1 over
1
3.
over
So you know you have to separate. So this will be equal to, okay, 1/3 or minus 1/3. Okay, that is your value for R. And I believe, forgive me, once we know R, okay, these two values, you can use it to predict our A because you come and substitute that one in here. So let me continue, do one and ask you to continue with the other one. So if what your R, okay, is equal to 1/3, the positive value, your A, okay, will be equal to 24 over 1/3, okay, Q. I hope you are with me, my professors.
Yes, please.
Okay, Prof. Amma, your hand is up.
Mr. Hackman,
Yes,
please, the
please.
value of R. Won't you give it an equation?
This one, oh no, because you have two values. Okay, that's the more reason why, and we will split. So we'll know when you
No,
are substituting, we'll know.
like you'll be like 2, maybe 3 into 1A.
No, I get your point. If you come and write, okay, you label this one as equation 3. Okay. And you say that 1 into 3, then it means when you are substituting, you have to substitute plus or minus all together. You get my point?
Yes.
So here you saw that the previous one I didn't label it because I had two values. So if you had only one value, then you label so that you will come and write that into the other one.
Okay.
Safa.
Yes, please.
Okay, all right. So now, okay, this will give us A. So this implies that A will be equal to 24, okay, divided by 1/27. Am I right? And you can use your calculator, okay, at this point. So, but however, before you use your calculator, work on the power. So give us the whole of the denominator with the power. So give us this. Okay, don't use the whole of, that means don't feed your calculator with the whole of this and press equal to. If it has a power, deal with the power. You could have done that straight away if the power was 1. But any other power, deal with the power in the denominator, right? So it means use your calculator to do only the denominator and write its value before you come in. Okay, write the entire value. Is my point well made?
Yes, please.
Okay, so that gives us
648.
okay, 648. Okay, that is one value for A. So you go and do that of what the other one, if R is equal to minus 1/3. That will also give you, okay, A will be equal to 24 over, okay, minus 1/3 in brackets cube. Okay, so if you continue, Okay, here we are going to get what? A to be equal to 24, okay, divided by, okay, -1/27. Okay, so which will give us -648. Am I right?
Yes, please.
Okay, so at this point, you go and draw your conclusion. And because you have two distinct values for A and R, when you are drawing your conclusion, you have to be very careful. So you have to write therefore, okay, A is equal to the first A and the R. A gave us what? 648. But that gave us, okay, and its corresponding R is equal to what? I think the R was 1/3. Am I right?
Yes,
Yes,
please.
please.
Okay, or, okay, our second A give us minus, okay, 648. Okay, and, okay, our second R, okay, -1/3. You are done. Are we fine?
Yes, please.
Okay, so this will be it for this particular question. Okay, so we are done with this particular question. Okay, so this one is similar to what we just did. Only that here, forgive me, you are asked to find only the first term. So you find A. Okay, so study the equation that you will generate. So assuming, let me go back, forgive me. Let me go back and use this one to drum home my point. Assuming with this question, you were asked to find the possible values of A without the R. Okay, then this is what you would have done. At this point, okay, if you are smart, which I know you are, okay, I will rather make R the subject from one of them and go and substitute. So that I will get, if you make R the subject, it means you are solving for A. You get A directly. You get the point?
Yes,
You get
sir.
A first, okay, before you do, okay, what is not necessary. Because if you go by this route, you have to find, okay, A first before you come and find what's your R. Okay, so take note of that. Sorry, if you make A the subject, you have to find R first before you come and find your A. Let me put it that way. So the one that you make the subject, that's the one that you find later. You get the point?
Yes.
Okay, however, if you think, okay, the other one is easier to find, okay, find that one and go and use that one to find the other one that we are looking for. It is always better to play it safe. Okay, if you are not matured, especially. Okay, Prof. Amma.
Exactly, please, I want to suggest something.
Okay.
So see the AR raised to the power 7.
Mm-hmm.
The R raised to the power 7. We
Mm-hmm.
can break it down into R cubed plus
Perfect.
minus R
Perfect.
4.
Perfect. Okay, so this is what she means. Those of you who don't get it, briefly. Okay, you can do that. That is the best matured way. And the next time, if I send this, to you, or it comes in the as I am giving you marking scheme, that will be the way that I will solve it. What she said, so that will give you another option. That will be the best option. So she is trying to say that you can see that this can contain this. Okay, I can write what I have here as, okay, let me use this one instead, because I'm using these two equations. So I can write from equation 2. Please listen and listen well. Okay, thank you, Amma. Okay, so more maturity in that. So from equation 2, I'm writing as if I'm presenting my solution, so that if you want to adapt, you know what to do in terms of presentation. From equation 2, I can write that one as, okay, 27, okay, A R, okay, cube, okay, times R to the power 4. Do you agree? Okay, and that will be equal to 8. Do you agree? Hello, do you agree that what I have here is the same as this, but in a different form? My professors, are you there?
Yes.
You agree? Okay, but you can see that AR cube, okay, is 24. Can you see that?
Yes.
Okay, however, hello, someone called, or okay, so at this point, okay, here, if you want to go this route, when you get here, before you label your equation, okay, make sure you write the equation as 27a, okay, r, okay, cube, okay, into, okay, r to the power 4 is equal to what? 8. And take note of this. We'll do binomial theorem, so we'll be using this concept. So r to the power 4, not r4. So at this point, I label this one as equation 2. Then I'll go and write equation 1 into equation 2 because I can see 1 in 2. So that will give me, okay, 27. AR cube is what? Is 24. So I put 24 there. Then r to the power 4. You get the point? So that is also allowed. You end up getting the same results. Okay, so thank you very much, Amma, for that wonderful observation. Okay, and matured, okay, observation. Okay, so we are going to end here. Unfortunately, this is all that time, okay, allowed us to do. Okay, so I will send you the other one. I think we have to do more. So in our next meeting, okay, we'll solve more questions. It's better. Why the rush? Okay, let's make sure that all our marks are protected and the questions are carefully selected for you to know everything. So until I exhaust it, okay, I know that you'll be deficient in a way. So in our next meeting, we'll continue with the GP. Okay, the rest of the questions, because we have more than enough questions. Okay, more than enough. Okay, questions that we are supposed to work on. However, this will be your assignment. Okay, this will be your assignment. So I will send this one to you for you to try. Okay, and you submit, God willing, this evening. Okay, so on that note, okay, thank you very much once again for making the class a success. Your contributions, suggestions, everything, okay, cherished. Okay, so bye-bye. God bless us all.
Bye.